Hi and welcome to this tutorial. I'm going to go through the section C of the sample paper which was taken in October 2019. This paper was set by the State Exams Commission but no marking scheme was ever released. So I'm basically just going to do a suggested answer. I'm sure there's many other suggested solutions as well, but I'll have a go at one way of getting through the question. So basically question 16. According to a recent report in the Irish Independent on the 19th of August 2019, 1 in 4 children and 3 out of 4 adults in Ireland are overweight or obese. This causes a significant increase in illness such as diabetes and heart disease. To determine whether a person is overweight or obese, a measure called body mass index, BMI, can be used. BMI is defined as body weight in kilograms divided by the square of the body height in meters. If the height is given instead in centimeters, the formula can be for calculating the BMI is BMI equals weight over height squared multiplied by 10,000. Just checking, yeah, that's 10,000 there. Yeah. So part A then, and you're given some code in your exam. So when you sit down at your computer or your laptop or whatever device you're doing it on in your school, in your exam center, usually probably a computer, a desktop computer, you will have a file called 16a.py. So you open the file in Tony and this will already be pre-coded on or whatever editor you're using. Most people will be using Tony, and you open up this file and this is what is pre-coded. Now, I cannot stress the importance of actually reading the question, just because the coding section won't take that long, particularly in this year 2022, because it'll be shorter the questions. So please take the time to actually read the text as well, because sometimes the key message can be in the text. This program is designed to calculate and display the BMI of a person whose weight is entered by the end user and whose weight is 180 centimeters. A sample run of the program is displayed below. The user enters the value 90 kilograms for the weight and the program displays the resulting BMI. So if I go over to Tony, I have this open and I'm just going to run it. I have to save it first. I'm just going to save file. Save as, and in here then when you're saving it, it'll be your exam number. So I'm going to pretend that my number is 1 2 3 4 5 6, and then usually it's just underscore (16a). Okay, so please make sure when you're saving it you have your exam number at the front of it, and you will be saving to a USB drive as well, which I don't have a USB plugged in at the moment, but you will be doing that in practice with your teacher. So enter your weight in kilograms. So what I'm going to do is I'm just going to run the program first to make sure it's actually working. So it says here that a sample run of the program, entering the weight 90, and it should give me 27.7778. So if I do that, if I pop in 90, I get the expected outcome, and it's always the first thing to check that your code is working the way it's expected. So now I get on to the questions. So modify the program to do the following. Insert a comment to say read weight in the appropriate location in the program to show where the weight is input. So the input for the weight is here. So the comment is just hashtag read weight, and I'm going to put in answer to part 1 there as well, just to tell the examiner in my comment where the answer to part 1 is, and it's actually outlined in the instructions for candidates that you should be doing that in your comments, so please follow that instruction. Let's move on now to question 2. It says, part 2, it says, currently the program, the value of the variable heights is hard coded to 180. Modify the program so that it prompts the user to enter the value for height. This value should be converted to an integer. When the program runs, it should look as follows. Enter the weight in kilograms is 90, enter the weight in centimeters is 180, BMI is 27.77778. So we want to change it so that it is hard-coded, not hard-coded, but that the user enters the value for height instead of it being hard-coded. And the value should be converted to an integer. So I'm going to pop back over to Tanny. And here, instead of my height being hard-coded to 180, I'm just going to pop in here. So I'm just going to take out the 180. And it's really similar to what we have up here for weight actually. So it's just int input. And I want to ask them to enter the weight. In centimeters. Sorry, I just missed the bracket. Please enter the weight in centimeters, and if I run that, so it says enter weight in kilograms, and I'm going to use the sample run that's given in the question. So that's 90 and then 180. And notice I've put my message exactly the same as the question there that was asked. So just be careful, to do it exactly right. So enter weight, I'm going to pop in 90 and I'm going to pop in 180, and I should get the same outcome as is given. So BMI is the exact same as it is supposed to be. So the output is correct. Part 3, by using the function round or otherwise, modify the program so the value of the BMI displayed is rounded to 1 decimal place. When the program runs, the output may look as follows. So now we want to round it. At this point, I would direct you towards your Python referencing guide and look on that for a little bit of help for the round function to make sure you know how to do it. There should be a little bit of help there. So I'm just going to open it up. We just have it opened here, the Python referencing guide. And on the second page there, you see under built-in functions, there's a round n1 to n. This returns n1 number rounded to n digits. So whatever number I wanted rounded, the number of digits I want to round to goes in here, and the number I want to round goes in first. So it's round, then my brackets, the number I want to round, and then the number of digits I wanted. So if I pop back into Tanny and have a little look here, my question asked me to round the BMI, so that's the number I'm looking for in Tanny. So my BMI is here, so I'm going to put round bracket around it all, and inside my bracket I'm just going to put a comma, and then I want it rounded, and I'm just going to check my question. It says to 1 decimal place. So all I simply have to do is pop in a 1 there, so round, put my brackets around the whole expression, and what am I doing? I'm rounding everything else, all of this here, I'm rounding it to 1 decimal place. So if you want it to be really particular, you can put a bracket around the rest of that, and then let's run it. Enter your weight in kilograms again, use the sample. And there we have, it is rounded to 1 decimal place. So part 4 is next. Before I move on, I'm just going to remember again to pop in my answers in here in my comment section, just for the examiner to know where I'm answering them. So parts 1, 2, and 3 completed now. And I'm moving on to part 4. So part 4 says, by using the function pow or otherwise, replace the expression height multiplied by height with an alternative but equivalent implementation. So there is actually two ways of doing this that stand out very quickly to me. I'll go ahead first of all and I'll use the POW function, and I'll show you where that is in the Python referencing guide first of all. So if you open up your referencing guide, and down here you have your POW. So if anything comes up that you're not sure of, the first thing you do is go to your referencing guide and it should explain it to you. Now it tells you that POW bracket N1 comma N2, that returns N1, so whatever's in the first position inside your bracket, it returns that to the power of whatever is the second position inside your bracket. So if I want something to the power of 2, say x to the power of 2, if x is my variable, then it's going to be POW x in the first position and then 2 in the second position instead of N1, N2. So that's what that expression means. I just might show you that very quickly. So the POW of N1 to N2. If, for example, you wanted to get your variable was called x, and you wanted x squared, well, what you would do in Python then would be just POW. The first position would be your x, and the second position would be whatever number you wanted raised to. So that's how you would write it in Python. So the variable that you want raised, and then the power goes in there. So that's what it means. So let's apply that now to Tani in this question. And I wanted, instead of height by height, I wanted height to the power of 2. So it's just, I'm going to take brackets off that for a moment. I'm going to delete one of the heights, and it's basically POW height comma 2. If you want, you can put brackets around the entire expression, and if I run that and just check that it works, just need to move down my screen. So the output we're using again is the sample code, and it's working fine, so it hasn't changed. I'll just run it again with the previous sample runs, make sure it hasn't changed anything. So that's one method of doing it. There is another method that you could do. So if you wanted the other method that you may have seen before, you might be more familiar with it. It doesn't use this power, POW. What it simply does, and I'll just change it just to show you, it's height star star 2, and you run it and put in your 90 and your 180 again, and you get the same answer. So either method is fine. You can either use the POW or you can use the height star star for raising it to the power of 2. That's another method of doing it as well. Either method is fine because it tells you can use either method. So in here I have answer to 3, and I have answer to IV as well, number 4. And either method there is perfect. So you can do it that way or use the POW, whichever you're more familiar with. And remember, POW is on the referencing guide, so that might make that easier for you. I'm just going to move on to part 5 of question 16A from the sample paper in 2019. So it says, incorporate the following function definition into your program and insert a line so that the function is called before the user enters any data. And it actually gives you the function here. And all you have to do is basically type that into Tani, into your program, and then you have to make sure you remember to call it. So when the program's run, this is up at the top, welcome to my BMI calculator. So I'm just going to pop it in here. Obviously you would type it out. I've just copied and pasted because I have it open on my PC. I'm going to put in my comments. This is part 5. And this is the previous line. And just to show you, when I run that now, it doesn't display the message at the top. So I need to remember after I pop it in that I just need to run it. And when I put in the name of my function, which is display intro, it displays it down here. Then welcome to my BMI calculator, enter your weight in kilograms. I'll say my weight is 90 and the input of centimeters is 180. My program is working perfectly. So it gave you the first 2 lines, and all you had to remember was to call your function after you had it popped in. So again, I'm just going to comment that that's the answer to part 5. And I'm going to move on then to the final part of section A, part 6. A BMI number alone might not mean much to the average person. A more meaningful output might be one of our BMI categories: underweight, normal weight, overweight, or obese. Extend the program so that it displays the BMI category according to the BMI ranges in the table below. So you have your weight and you have your parameters on this side then. The table below shows your expected BMI values and categories for some sample weights and heights. So basically what this is telling you is you need to put in some sort of code so that your computer, your program will recognize whether your BMI means that you're overweight, normal weight, underweight, or obese. And when you have that code in, you check whether it's working. You test it by popping in the weight and the heights and seeing if they give you the expected results. It gives you an expected outcome down here as well. So we need to come up with a way. How are we going to program our Tani code here so that it displays underweight being less than 18.5? So let's just begin by having a little look at the sample program. Down at the bottom it just gives an output, say for example normal. So I don't need to change anything else at the top of my code. That's all fine. And then I just want to display a message at the bottom, whether it's underweight, normal, overweight, or obese. So I'm going to set up a little if statement in here, little loop, and I'm going to say if, and remember it's my BMI that I'm checking. So if BMI is less than 18.5 to begin with, put in my colon. What do I want to do? Well, I just want to simply print out that the message is underweight, and I'm just going to be very particular and just check, yes, so it's a capital U for underweight. Just again, that's only something very tiny. So the message I want to print out there, if that is the case, is underweight. Else if the BMI is greater than equal to 18.5 and the BMI is less than or equal to, and I'm just going to check my question, 24.9. So between 18.5 and 24.9. If that's the case, what do I want to do? I want to print that it is normal. Else if the BMI is between 25 to 29.9, the message is overweight. So between 25 to 29.9 is greater than or equal to 25, and the BMI is less than or equal to 29.9. What do I want to do? I want to print the message overweight. And the final thing is else, and I don't even need to put in my statement here because all of my other scenarios are looked after. If it's not underweight, normal weight or overweight, well then I'm sorry, but it has to be a simple print statement to print obese. And if I run this code and I check then using the sample code given in the questions, so the first sample code here is enter the weight to be 50 and the height to be 165. So weight 60, height 165. Weight 50, height 165. The outcome should be BMI 18.4 and underweight. And let me check. That's correct. The next weight I want to add in is my kilograms, is 70 and 170. I'm going to run my code again. And a 24.2, and that's saying normal. That's correct. If I run it again and I pop in 90 and 180, it should be 27.8 and overweight. 90 and 180, that's correct. And the very last one is 90 and 170. To run it, 90, 170, and it says obese at the bottom, 31.1. So my code is working perfectly. So when the program is run, the output may look as follows, and it looks exactly similar to that output there. And you are now finished part A of the sample paper from 2019 that took place in October of 2019 as a trial for the first computer science exam, and it was written by the State Exams Commission. Thank you.